Hey everyone, and welcome to Building SaaS on AWS with me, Gunnar Grosch, developer advocate here at AWS. And this is our bi-weekly show where I bring on AWS experts to talk about how to build SaaS using AWS. And this is a highly interactive show, so if you have any questions, any comments, you just put them in the chat and our AWS SaaS experts will do their best and try to answer those throughout the hour. And if you've been with us before, seen previous episodes, you know that this is highly technical, so we'll try to deep dive into SaaS specific topics. And this week, I'm happy to be joined by two returning guests, I guess, and one new guest. We have Ujwal, Anubhav, and Philipp joining us today. Welcome to the show, all of you.
Thank you.
Thank you. Welcome.
So we always do a quick round of introductions to let the viewers know who's with us. So Anubhav, let's start with you.
Yeah, sure. And thanks for having us on the show, Gunnar. So really excited to deliver the show today. So my name is Anubhav Sharma, and I'm a solution architect here at the AWS SaaS Factory team. And in my role, I help customers and partners who are building SaaS-based solutions on AWS by providing them technical expertise. So that's my role, and I have my colleague Ujwal on the call as well. Ujwal, do you want to go next?
Sure. Yeah, I'm Ujwal Bukka. I'm a solution architect with the AWS SaaS Factory team. I myself and Anubhav are from the same team. We, as Anubhav said, we help various partners and ISVs with their SaaS journey. Philipp, do you want to go next?
Yes, sure. Yeah, I'm Philipp Sacha, hi, and I'm a specialist solutions architect for IoT here at AWS. And I am supporting our customers and sometimes also partners, especially in the IoT area, because we have, meanwhile, a pretty large portfolio of IoT services.
And every show we do, we have one specific topic that we're going to dive deep into. And just based on what you're doing, Philipp, I think we gave a hint to what the topic is. We're going to talk about building multi-tenant architectures with AWS IoT Core. So that's the topic for this week. And maybe we should start just there to give a quick overview of what AWS IoT Core is, Philipp.
Yeah, sure. AWS IoT Core is a managed cloud service that lets you connect devices easily and securely interact with cloud applications or also with other devices. And we support several well-known protocols in the IoT area, which is MQTT over WebSockets, HTTPS, and also LoRaWAN protocols. So when you connect your devices to IoT Core, you use so-called topics. That's an artifact in the MQTT protocol to send or to receive data. So sending data is called a publish request, and you receive data by subscribing to a topic. You can think a little bit of it like a mailing list, where a lot of people can send a mail to the mailing list, and you can consume the mail and answer the email here. So this is a little bit similar to the publish-subscribe pattern in MQTT. And AWS IoT Core makes it also easy to forward your data to other services, because if you look at the diagram here, you can see on the left-hand side something like buildings or vehicles, which can send data, for example. And then you want also perhaps to send commands to your devices to control something, or you want to get the telemetry data that are ingested by your devices and store them. You want to analyze them. And we do have also a lot of services and within AWS, like AWS Lambda, like Kinesis or S3 to store data, or a NoSQL database like Amazon DynamoDB. We have a service in the industrial space, which is called AWS IoT Sidewise. And with IoT Core, it's pretty simple with the so-called rules engine to forward your data simply to another AWS service. So that does not require you to write any code. You use simply something like a SQL statement on your message, and then you forward the complete message or parts of the message to another AWS service, which you can use here to visualize your data, analyze the data, store the data. So, and as you have also all these devices out in the field, you also want to manage probably these devices or have an overview of your devices. And therefore, we do have a feature in AWS IoT Core, which is called the device registry. With the device registry, you can manage your things. So that means you create a thing in the registry, which is then a virtual representation of your physical device. And you can also add information to your device. You do not have only a thing name, but you have also thing types. You have also thing groups that lets you group together your things, for example, by a certain location or so. And then, as with a lot of other AWS resources, you can also add text to your devices. We will use also text in this workshop here. And AWS IoT Core is a multi-tenant service. So that means unlike EC2, for example, or RDS, where you provision a resource and you can provision multiple RDS instances, for example. In IoT Core, you have simply one service, and that there you get one endpoint, and you can use this endpoint to connect your devices, and all your devices and all the other artifacts reside in AWS IoT Core. So of course, even if you have multiple devices that talk to certain topics, you might also want to restrict what device what a device is authorized to do within the service. So that means you probably don't want all devices to subscribe to all topics, because you have certain devices that should not receive messages for any other devices. And therefore, you can restrict permissions with so-called IoT policies. They look similar to IAM policies. So you have either allow or a deny permission. You have some actions. You can also provide a resource. But they are artifacts of IoT Core. So that means you store them in IoT Core. And then you need to associate these IoT policies with your devices. And we are already at the authorization step. Before authorization, we have also authentication mechanisms for devices. We usually recommend to use X509 certificates. And then you would associate your IoT policy with an X509 certificate. And the X509 certificate, again, is then associated with your device. So you have the chain device, certificate, policy. And with that chain, you can define what is your device authorized to do in the service. Yeah, so far, a brief introduction from my side about IoT Core.
That was quite a lot still in a very short time. So one thing that you mentioned there, I just want to pick up on that. You mentioned that you have one endpoint per region per AWS account, meaning that AWS IoT Core in itself is a multi-tenant service, right?
Yeah, yes. But that means also every AWS account in every region has its own endpoint. So that means it's not like something endpoint ABC for all customers in all regions. We do have also an API which you can call to describe your endpoint. Then you get back your endpoint name. You can also find your endpoint name in the AWS IoT management console. And you can also, what is a pretty new feature, provide your own domain, your custom domain for your endpoint. If you don't want to have an endpoint for your devices, which ends in amazonaws.com. You want to have your own My IoT endpoint, mycompany.com. You can also create such an endpoint, but that refers back to the IoT endpoint from IoT Core.
Right. So let's talk a bit about some common use cases then for, well, when you build a multi-tenant IoT platform that uses AWS IoT Core.
Yeah, maybe I can talk about that, Gunnar. So, basically, assume a use case that you are a device manufacturer, right? And you are in a business of manufacturing devices. Maybe an example could be where you are, excuse me, manufacturing a device which measures the temperature of a building, as an example, right? Or maybe you're in healthcare business and you are manufacturing a device which you are selling to different hospitals, right? So in this case, what traditionally all these device manufacturers have been doing is they also ship a software along with the device, which you can install on premise, right? And you can just look at the readings or just whatever measurements the device is taking inside the industry or in a hospital or whatever use case that is, right? So, but now what all these device manufacturers have started to do is they have started to collect data from these devices inside their AWS cloud, right? So look at this example. So in this case, assume that you are selling these devices and these devices are installed, let's say in a building or a farm or maybe an industry. And we call these different businesses as different tenants, right? And this AWS cloud infrastructure is basically your, you as a solution provider, as a device manufacturer's AWS cloud, right? And you are now offering to collect data from these devices inside IoT Core. And as Philip mentioned, like you get an endpoint where you can use to collect data from all these devices, right? And now this data inside your AWS account is basically tenant data, right? So now you're talking about a multi-tenant use case where you have data from different tenants, different devices residing in a common place, right? And then what these device manufacturers are starting to doing these days is they are now building SaaS-based solutions on top of this data, right? So they might offer maybe some sort of analytics platform or dashboarding or just predictive maintenance of the devices, alerting on different measurements, right? So many use cases we are seeing in the industrial IoT healthcare domain. um, People are like going crazy, like just predicting the health of a patient, as an example, right? Figuring out if the device is going to be what's going to be the temperature from next few minutes and stuff like that. So there are so many use cases which you can offer as a SaaS based offering, just because now you have the data. So that's the typical use case we are seeing. And today specifically, so what we basically did was we understood that customers need help in architecting the solution, right, in terms of IoT Core. And just because Philip described, there are so many moving parts, and so what we did, we basically built a workshop which actually covers this yellow box I'm just highlighting today, right? And Ujwal will walk us through the workshop step by step. He'll write some code, he'll run some commands to actually describe what, as Philip mentioned, right? How do you onboard devices? How do you onboard tenants? How do you create certificate, and how the authentication works? So this is basically the high level use case and what we're targeting today.
Yeah, so maybe we can then talk a bit about what customers need to consider when they're building a multi-tenant IoT platform.
Absolutely, right. So as you can see, now you have different tenants, right? So obviously, first thing that you need to be careful about or considerate about is how to onboard these tenants, right? You need to be careful about collecting different logs and metrics about all these tenants, right? So that you can visualize the data in a proper way. You can do all those operational aspects inside your platform. But the most important of all is tenant isolation, and that has been the main focus area, which we have been, guiding customers through when it comes to multi-tenant architecture, right? Like you have all these tenants sending data inside your AWS infrastructure. Like, how do you make sure that one tenant is not impacting other tenant, right? How do you make sure the data for one tenant is partitioned across different tenants, right? And when I talk about tenant isolation, you can actually do that in two different ways when it comes to IoT Core. So the first way is you can just think of this AWS cloud infrastructure as multiple accounts, right? So I know that I'm kind of denoting this as a single box, but you can think of this as an AWS organization where you have multiple accounts, right? So then what I really mean to say is that each tenant get their own AWS account. And what that basically means, they get their own independent endpoints as well, as Philip described. So, and that gives you a natural isolation boundary, like you get one account per tenant. In those cases, obviously, the tenant isolation is taken care of mostly by AWS infrastructure, and you really don't need to be worried too much about the limits as well, right? But in those cases, what we have seen is that when you have tenants in the scale of thousands and hundreds of thousands, right, it becomes really challenging for customers to manage that many number of accounts, right? You have to provision a new account. For sure, you can just pre-warm some accounts and have them ready, but still, it's a lot of operational overhead and kind of impacts the agility having one account per tenant, right? So in this workshop, our focus is actually demonstrating how you can implement a pool model, basically, like how you can implement a model within a single AWS account where you have multiple tenants sharing the same IoT endpoint, and having all the data residing in a single AWS account.
But it sounds like what you're saying is that it is the same things that we're always talking about when it comes to SaaS. It's just from an IoT specific area of SaaS.
Yeah, I mean, what basically it takes within IoT Core to build that pool model is basically the focus of this workshop. I think you nailed it. Yep.
No, that's great. All right, so yeah, we are 17 minutes into the show. This is Building SaaS on AWS, and we're looking at building multi-tenant architecture using AWS IoT Core today. So I think I want to get to it. So let's jump into the workshop that you mentioned, Anubhav.
Yeah, I think Ujwal, if you want to share your screen and just jump right into it, I can stop sharing this boring slide. I know. I think.
Sure. Yeah. So yeah, thanks, Anubhav. So just wanted to let you know that the left side, what you're seeing is my AWS console, which is the Cloud9, and the right side is the workshop documentation. So usually when you start with the multi-tenancy stuff, the first thing you do is like onboarding a tenant. So onboarding a tenant, what it entails is basically provisioning various resources required for that particular tenant. So in this workshop, what we did is we provisioned resources for various tenants using command line CLI commands. But if you want to know about more about how you would build this workflow of how you should orchestrate the workflow of onboarding process as a unified experience, I would suggest you to look at some of the other resources like a serverless SaaS reference solution or the EKS SaaS reference solution, which is built by my teammates. Where we talk about how you need to build that whole end-to-end workflow, where you can see the unified experience. But in this workshop, we want to keep things simpler. So we used AWS CLI commands to provision the resources. So coming back to this workshop, as Philip mentioned earlier about the IoT things and the certificates, so certificates and also attaching the certificate to the thing, as a part of this onboarding, we would do a bunch of things. So the first thing we would provision is the IoT thing, and we provision a certificate. We'll attach that certificate to the thing, and then we create IoT policy, and then we'll create a thing group and a billing group. So let's deep dive into those individual things here. So what you're seeing on the right side here is the documentation. We're creating a thing group. Let me define what the thing is first. The thing is basically representing a IoT device in the AWS core. So it's basically like, it can be a light bulb or a sensor. So the construct which we are creating here through this command is called a thing group. So what we are doing is we are creating a thing group for each tenant so that we can group all the things related to that particular tenant under the thing group, and then tag that with the tenant ID here. You can see that we are tagging that thing group which we're creating with the tenant ID and its value. You will see in the rest of the lab how we will use these values to do various other good stuff. So let me copy this this command and run on the Cloud9 just to create the thing for this thing group for this particular tenant. So that created a thing group for the tenant one, and there will be some cases where you will have use cases where a tenant will have subtenants. So in that case also you can create a thing group for those subtenants. So this is the command which does that for you. So let me run that command here on the Cloud9. And the other construct which we are creating in this workshop here is a billing group. Let me provide some background here. So in a multi-tenant system, you need to know how much it costs per each tenant. So you need to find out the cost per tenant. So in that case, using this billing groups construct would be very helpful in the IoT world, because what we are doing is like, it's basically a billing group is a construct where you will create a billing group for each tenant, and then we'll add all the things into that billing group of the particular tenant. So basically you create a billing group, and all the things of a particular tenant will attach to this billing group. And again, it also has the required tags like tenant ID and tenant value. And in the end, in the workshop, we will show you how you can use this billing group to calculate the cost per tenant. So basically, we'll use another AWS service where it will generate some reports with these tags, and you should be able to attach that. It will be more clear when we run through that workshop. There is a separate section for that in the workshop. But for now, let me run this command to create the billing group for tenant 1. And then optionally, you can create custom domain. If you remember, Philipp has mentioned that for IoT Core by default gives you a device endpoint per account and per region. But depending upon your use case, you can also create custom domains. And again, these custom domains for basically a domain for each tenant you can create, and these custom domains can point out to the device endpoint.
These custom domains are actually, just to maybe add one more thing, like these custom domains are very helpful when it comes to migration, right? So let's say your device is already communicating with some other domain and you just want to migrate to AWS, you can create a custom domain which is same as the one your device is using, and then you can just ease off the migration. So I think that's a good migration story as well.
Sure. Yeah. So moving on. So until now, what we did is like we just created a thing group and also a billing group. Now let's create the thing. You can see that the command here is basically creating a thing. I would like to point your attention to these attributes in the thing, where we are setting the attribute as tenant ID and tenant 1. Just hold on. I'll come back to this one. You will see in the rest of the commands how we will use this to enforce to create the IoT policies. So for now, let me create this thing by running this command. So that's created. And then now the next thing what the command here it does is basically create a certificate. So basically we are using certificate-based authentication. So we are by running this command, we'll create a certificate for this particular thing, and then we'll run another command to attach this certificate to this thing. So let me run this command here. And then this command is basically attaching this certificate to the thing.
And you're also downloading the certificate, right, Ujwal? Like as part of this command, you generate the certificate in IoT Core, but also download the key and the certificate file, right? Which you use.
Yes.
Okay.
So yeah, you basically I'm setting this as an environmental variables here because you need this certificate when you are again when you're publishing something data to your IoT Core. You need this certificate so that right. IoT Core can do the authentication piece.
So that's used for the actual device provisioning.
Exactly.
Yes, this is a very important step. And there, as Philipp was describing, there are multiple ways you can authenticate. This is like X509, basically the certificate-based authentication we're talking about.
Yeah.
And one thing to mention, it's not covered in the workshop here, but this is an easy way. We do provide certificates and private key from IoT Core, but you can also bring your own certificates. You can also bring your own certification authority in case you want to manage your own PKI. So this is also possible with IoT Core.
Yep. So after we created the certificate, and then if you remember, Philipp mentioned about there are IoT policies which enforces the proper permissions for this certificate. That's what we are doing here. Basically, we are creating an IoT policy. If you look at this IoT policy here, it basically has two things, two permissions. One is allowing to connect, and another is to publish. So let's build deep dive here. So what you can see is for the connect permission, the resource part of it, you can see that what it is saying is basically we are using a IoT policy variables, and we are dynamically configuring the thing name. So the thing which we created, we are through this condition, what we are saying is like basically only you are giving the certificate permissions to connect to a thing with this thing name, and the other permission is the publish. And if you look at the resource part of it, let me highlight that part here. What we are saying here is we are pulling in the attributes which we defined in the thing with the name as tenant ID. So if you remember, when we are creating the thing, I pointed out that the attribute which we mentioned is the tenant ID. So we are here with the IoT policy variables, we are dynamically pulling the tenant ID and then using that in the resource. And then the rest of the thing here is again the thing name. So to summarize, what we are what this permission is saying is like, this certificate can only publish messages to a topic which starts with the name as tenant ID, which is coming dynamically, / the thing name. So this certificate can only publish the messages to the topic with tenant name / and its thing name, and it can only connect to that thing with that thing name.
Yeah, this naming convention is kind of important, right, Ujwal? So basically, you take the attribute tenant ID from the attribute dynamically, and just making sure that any topic for any device for this tenant, have that consistent naming convention where it's like tenant ID / thing name, basically, right?
Yeah, because you will see in the lab, like by having this convention, it will help you in later, do the proper isolation and data partition. So yes, thanks for pointing that out, Anubhav. Yeah, and then this command is basically attaching this policy to that certificate here. So let me run that command. And then now the last, these two commands are basically, if you remember previously, we have created a thing group and a billing group. We are just adding this thing group, and we're adding this thing which we just created to the thing group and the billing group. Let me add that thing here, run this command. So yeah, those are the some of the resources or constructs which you create as a part of the onboarding process.
So you've created the tenant with the IoT, what is it called, the thing group.
Yeah.
And you've created the actual thing, and you've created a policy attached to that. Yes. And now the next step would then be to provision the devices using those certificates, and that would then reside within that tenant.
Yes. So
yeah, sorry, go ahead.
Now, basically, yeah, just to summarize, we created a thing basically which represents a device, and then we created a certificate for that. And then for that certificate, we have attached the IoT policies. And then, so now our thing is ready to publish the messages onto the its particular topic, so that things can run.
Yeah, that initial step of provision thing groups and billing group is a one-time thing, right? That's something that you will only do as part of onboarding your tenant, basically, right? So typically you'll have some sort of onboarding module where you onboard a new tenant, a new business into a system. You'll build some sort of microservice where you will, and as part of that whole, and you will maybe also save the tenant information in a DynamoDB table as an example, right? And we have done those. We have built those modules as part of some of the other reference solutions like the serverless and the EKS one, which we have talked before. But in this case, we are only talking about the specific two or three different things, basically, like how do you provision a new thing group and a billing group as part of that whole onboarding process, right? Yeah.
So maybe you can show then how tenant isolation is implemented. So maybe we can see how we're enforcing that tenant isolation.
Sure, yeah, definitely. Let me move on to here. Just before I go deeper into the tenant isolation, just wanted to paint picture on like what are the different resources or provisioned here, so that it will be a good overall overview. So as I was saying, we have created a tenant for tenant one. We have created a thing, and then we created a certificate, and it can we said like we defined the topic name should be tenant one / the thing name. And then we'll also provision, as a part of the workshop, what we'll do is also we'll provision an IoT rule. This IoT rule is basically looking at all the topics for that particular tenant, which starts with tenant one, and then pulls the data from all those topics and sends the data to the Kinesis data firehose, which uses the dynamic partitioning concept to basically it pulls using the dynamic partition concept or the feature. It basically takes the tenant ID from the payload, and then partitions the data by tenant ID as a S3 bucket prefix. So basically, with that tenant ID as a prefix, it will push all the data into S3 bucket. So that's the overall the layout here. But for the tenant isolation, what we will do here is that we'll show you that using this tenant one thing, we'll try to drop the message onto this topic. Since the certificate, as we seen earlier, since the certificate has the IoT policy which allows it to drop the message onto this topic, we will see that the message goes through. And then we'll do is that we will quickly create a tenant 2 thing also. And then what we will do is we will use this tenant 1 thing certificate to drop the message onto the tenant 2 thing 1 topic. So basically, we're trying to cross that boundary here, trying to jump into the tenant 2's world. And then you will see that IoT policy kicks in and hey, gives you an authorization failure saying that hey, you're not supposed to cross this boundary. So yeah, let me run through those instructions to see what I'm talking about here. Oops, I'm trying to minimize this guy here. Giving me a hard time. Give me a few minutes here.
This is just to show that it's live.
Oops. How do I minimize this guy? Okay, let me do one thing then. Let me change it. Sorry, guys.
No worries.
Okay.
Yeah, there
All right. There we go. I guess it wanted to embarrass me for a little bit. So yeah, there are some initial steps which configures the logging for the IoT core. So basically, run through these commands. I've already run these commands earlier, which basically enables the logging in the CloudWatch logs. We'll skip through this one, and we need to we need the root Amazon root CA certificate. In order to, when you're publishing the message, apart from the device certificate, you also need to send this Amazon root certificate. So that's the reason I'm running this command here to download that certificate. And then what we will do is we will go to the AWS console and the IoT core and subscribe to this tenant 1 thing topic. Before we publish the message, we'll subscribe to the topic, and then we'll publish the message, and we'll see that it will drop down to the topic. So this is AWS IoT Core. If you go to the MQTT test client, just enter the topic, and you can subscribe to that topic. And now, oh man, this is again embarrassing me. Come on.
No.
Chrome and Mac are not cooperating together, right?
I guess I won't expand from now on. Just come on, please.
Maybe you can just switch between them.
Yeah.
Yeah, I'll do one thing. Okay. Let me. All right. So let me do one thing here.
So in the meantime, you subscribe to that topic, so we'll be able to see in the test client any messages that are published to that topic.
Yeah. So basically, now this command is basically what it does is uses this root certificate and the certificate which is created for the thing, and then publishes that message to this topic. So let me do that run on the Cloud9 here. So it has successfully published the message. And if you go to the AWS IoT Core, you can see the message drop down to that topic.
Yeah. And we use those certificates basically to publish the message which we created before.
So now let's do the test of the the authentication. This is let's provision the thing for the tenant 2. We'll provision a thing by running this command. That is provisioned, and then And now this command here, basically what it is doing is it is using the certificate of tenant 1 certificate and trying to drop the message onto tenant 2 thing. So basically it's trying to cross that boundary. Let me run this command, and this should throw an error for us. And then if you go to the CloudWatch logs, you'll also see there. So you can upfront see here, it's not much information here. It says, the connection was lost and, some error. But if you go to the CloudWatch logs, so AWS Core, AWS IoT Core logs the things with this log group name. That's AWS IoT logs v2.
And also, perhaps I'd like to add that the disconnect from the device is initiated by IoT Core. So if you violate an IoT policy, if you publish, for example, to a topic you are not allowed to, or subscribe to a topic you are not allowed to, then the service will disconnect your device. Therefore, you can see the error in this client.
Yeah. So yeah, you can see here that it gave an authorization failure, saying that you failed to connect to the tenant 2 thing with an authorization failure, because we used, as I said, we used the tenant 1's thing certificate to cross that boundary and publish the message onto the tenant 2's topic, and that's where it the IoT policy kicked in and then stopped that cross boundary. That's how, yeah. Gunnar, that's how we we can enforce the tenant isolation in here in this.
And this also goes to show that the tenant name or the topic name isn't secret. It's not something that will allow others to publish to those topics.
Yeah, that's exactly the point, because now you're controlling that by the certificate, right? And the certificate have the authority to publish to the right endpoint or the right topic in this case, basically. Yeah.
So moving on then, Ujwal, what's the next topic on storing data, maybe?
Right. Yeah. So yeah, as if you remember the overall picture which I shared earlier, since we have talked about the isolation piece until this point, now I can show you about how this IoT role pushes the data to the Kinesis firehose. From then how the data gets partitioned into S3. So for that, so as I said, we were storing this data in S3 bucket. So this command here in the workshop basically creates this S3 bucket. I've pre-provisioned some of these instructions here. So I'll just run through this one here. And then there are a bunch of roles which we need and for Kinesis firehose to push the data into S3 bucket, and also some roles for Kinesis data firehose. Those are the, these instructions takes care of those things. And then this instruction here is basically creating this firehose, which can push the data onto the S3 bucket. But here, I would like to point out into a few things here. If you look at this highlighted piece and also the highlighted piece here. So what this is basically the dynamic partition feature, which I was mentioning earlier. What it does is basically when the input payload comes into the Kinesis firehose, it looks at that payload and gets the tenant ID from that payload and uses that tenant ID as a S3 bucket prefix and pushes that data into S3 bucket. So basically it partitions the data by the prefix name as tenant ID. So this configuration and this highlighted configuration and the highlighted configuration here implements that piece. And then moving on here, so the last piece in the puzzle is that all this thing starts from the IoT rule. So you have this IoT rule, then you have the Kinesis firehose, and then S3 bucket. I talked about how Kinesis firehose looks at the payload and gets the tenant ID. So all the things starts from this IoT rule. So let's look at this IoT rule which we are creating. So what this basically, overview of what this IoT rule does is basically it tries to pull the data, all the data from all the tenant one's topics. As I highlighted there, you can see that we have the topic name as tenant one /hash. What it does is basically this rule is trying to pull the data from all the tenant one topics, and then what it is again, it also not only it is pulling the data, but also it does something else. What it does is it tries to append the tenant ID. what this whole the highlighted piece is doing is, if you remember, we used a convention for naming the topics. We started with the tenant ID / the forward / and the thing name. So what this highlighted code is doing is basically from the topic name, it's trying to get the tenant ID and then appending that tenant ID into the payload. So if you can visualize this, what is happening is, like, when you publish the data onto a topic from a thing or from a device, it's going on to the topic, and on the topic there is a rule looking at that, and it is pulling the data from the topic and also dynamically appending the tenant ID without any of the awareness. It's just appending the tenant ID to it, and then that enriched data with the tenant ID is going to the Kinesis Firehose, and the Kinesis Firehose dynamically looking at the tenant ID and pulling the tenant ID and then partitioning the data by the tenant ID in the S3 bucket. So what we'll do here is now, I've pre-provisioned some of these instructions because Kinesis Firehose takes a few minutes to provision. So I've pre-provisioned a few things. What we will do is, we'll test this. Basically, I will try to run this command a couple times, and then we'll go to the S3 bucket and then see how the data is partitioned. So let me go to the Cloud9 and run this couple times. And actually, in fact, we've been running this for a couple of times, right? So we should already have the things in there. So this is the S3 bucket, which I've created for this one. So yeah, you can see that, it already created a prefix with the tenant1 ID. And then, yeah, it has some of the data. Looks like, let's modify it. Yeah, there is some data today at 9:37. And usually it takes around 60 seconds to show up this data, because Kinesis Firehose, what it does is it tries to buffer the things to be more efficient and then push out the data. So you might not see the the latest information, but you can see that at 9:35 we have run sys commands and it made it to things. So that's how we basically implement the data partitioning, and I hope you got a clear picture of how we are pulling the tenant ID and partitioning it by the tenant ID.
And then from there, based on the use case and so on, you can use all of the S3 features, of course, to be able to separate use policies and so on.
Yep.
Yeah, I mean, we just demonstrated S3 as one example, right?
Yeah.
IoT Core can push data, and Philip can keep me honest here, right? It can push data to multiple AWS services, like time stream or even data stream, and like DynamoDB and multiple services, Elasticsearch. You can quite a few services are supported, which IoT Core can ingest data to, and you can build your data story after that, right? I mean, this is just the ingestion part we are talking about right now, and just partitioning the data properly. But then the whole machine learning and analytics aspects is something that will be on top of the data, basically.
And also, if a service is not supported out of the box by the rules engine, or you have your own setup, your own custom built database or so on, you can then forward your messages, for example, to a Lambda function, and then from a Lambda function you can ingest your data in nearly any other system. For this does not work well when you have a lot of messages, because for every message you will call a Lambda function. But also here you can use some services from AWS to batch your data. You can send your data to a Kinesis stream and then process multiple messages at once with a Lambda function. And then you can work around in case a target is not supported by the rules engine.
That's great. All right, so this is Building SaaS on AWS. We are talking about building multi-tenant architecture for AWS IoT today. And on the initial slide we looked at, we also had monitoring, logging, and so on. So maybe we can have a look at how we're using tenant-aware logging and monitoring, Ujwal.
Yeah, sure. Yeah. So as I mentioned earlier, if you go to the IoT Core, if you look at the settings here, what you can do is you can configure the logging level. I'm just showing it in the AWS console, but in the workshop, you can set the logging level. But in the workshop, we run the commands, command line CLI commands to set this logging. Once you configure this, it starts pushing the logs into the CloudWatch. And also in here in the workshop, you will see that we talk about how you can enable specific logging for a thing group. Basically, you can change the logging level based on your specific resources for your thing group. You can do that. So now that we have been running this, these publish commands couple times, we should already have some data in the CloudWatch logs. Earlier, we tried to look at the log groups and then looked at that authentication failure message. Rather than looking at the log groups, you can also look at the CloudWatch log insights. Run this log insight query as shown in here, and to look at all the data related to that particular tenant. The query here, basically what it is doing is looking for this word tenant one in the message to look at all the messages related to that particular tenant. So I can quickly show how it looks like in the AWS console. So as I mentioned earlier, CloudWatch pushes all the logs with this log group with the name AWS IoT Logs v2. Instead of looking at the log groups, you can also go to the logs insight where come on.
No rush.
Yeah, and select that logs IoT v2. Basically, I'm selecting that particular log group, and then run this command, basically, which is looking for the messages with the tenant one. Just as an example I'm giving, but you can see all the logs which has that information. So in this, you can run whatever, depending on your requirements, whatever the use case you have, you can run through this query and get meaningful information out of these logs. And then that's the logging part. And for the tenant-aware monitoring, before we move a little bit further on how we design the workshop for the monitoring, we would like to talk a little bit about the AWS IoT Device Defender. Philipp, do you want to elaborate a little bit on what the IoT Device Defender is and how the users can use that, or the customers can use that?
Yes, so AWS Device Defender is a service for security and your IoT setup, and it monitors or can not only monitor your devices. You can run, for example, an agent on your devices that collects data, but security already starts in the cloud. So we talked about, for example, IoT policies. You can build very open IoT policies. Of course, you should always build these IoT policies according to the least privilege principle. And Device Defender has several checks built in. You can find, for example, open policies, or you can find certificates that are about to expire. You can check a certificate revocation list in case you use your own certificates. So these are all security measures that start already in the cloud. And then you can also take mitigation actions. So for example, to disable a certificate or deactivate or revoke a certificate once you have a device, for example, that has a certain usage pattern that falls out of your normal range. So you can either define your own pattern. So if you have a device that sends, for example, every minute a message, and it starts to send every second a message, then it might have been compromised. You can set up such so-called behaviors manually, or we have also an AI ML-backed mechanism that can learn over time your message pattern, how your devices behave. And then if your devices fall out of this range, then you can also take some mitigation actions. So that's what Device Defender is for, to make your environment secure and also to take automated action, like deactivating a device when you assume your device has been compromised, you can also define your own mitigation actions with Amazon SNS and with a Lambda function. So that might be you also need to send a technician on site. So you create, for example, a ticket and a trouble ticket system automatically. So there are a bunch of checks also in Device Defender. And apart from the available mitigation actions, you can also create your own ones because it's more or less than driven by Lambda.
All right, thank you.
And
So
go ahead, Ujwal.
Yeah.
Sorry.
So for just one last bit here. For the workshop, we haven't used the AWS IoT Defender, but what we showed here in the workshop is what we'll show you in the workshop is basically how you can use CloudWatch alarms to just monitor some of the things of some of the tenant activities. So what we did in the workshop is basically we'll try to monitor the IoT rule metric called topic match and build a CloudWatch alarm out of it. And the command here is basically building that alarm. So what this alarm is basically looking at is, this alarm when there is we are specifying this topic with tenant one. So it is basically monitoring all the topics of the tenant one, and if the number of messages onto the topic are more than a certain threshold, in this case the 5. And if it is within that specified period of 30 seconds, it will generate an alarm. So basically, if the number of messages are more than 5 within a period of 30 seconds, it will generate an alarm. And you can run this. You can run this. You can create this alarm and then run this particular command or publishing this message within within a second or couple seconds. If you can just try to blast this messages more than 5, you will see an alarm on the CloudWatch, something like this. Usually it takes around a minute or so to show up this alarm. In the interest of time, I'm not showing that in the CloudWatch, but when you run through this workshop, you will be able to see this particular alarm when it reaches that threshold. So yeah, Gunnar, so those are some of the things we cover regarding the logging and monitoring in the workshop.
That's great. Yeah, I've shared a link to the workshop. I let people have a look at that, go more into depth with it on their own as well. But we're quickly approaching top of the hour. I just have a few more questions. I think, Anubhav, you mentioned early on about using tenant IDs on tags. So can you tell us a bit about how that is helpful?
Yeah, I mean, I'm also sharing my screen if that's helpful. Thanks, Gunnar. Yeah, I mean, in the interest of time, I won't go, do all these steps, but I'll just talk about, why this is important, right? So Ujwal walked us through a good high-level use case of data coming from a device, isolated and partitioned properly, right? I'm going to talk about some couple of other, you can call them as specific or advanced use cases, which you might encounter while building a multi-tenant architecture. And the first one is, how do you restrict access to tenant resources, right? So as an example, if you can see here, right? I mean, this is the typical example where, in this case, this is my user, which in this case is my Cloud9 instance, right? And it's trying to list all the devices within a thing group, right? So that's the use case which I'm going to target right now. And if you might remember, we tagged our thing groups with tenant ID as tenant1, right? So I'm going to leverage the attribute-based access control feature within IAM to restrict access to only those thing groups which are tagged by tenant ID as tenant1, right? So in terms of the steps that are required to do this, so I'm just going to give a high-level overview at this point. So as first thing that you have to do is, obviously, you need to create an IAM role which can actually list those things, right? And it is important to understand what that IAM role is doing. So if you pay attention to this assume role policy document, now each IAM role have two parts. The first part is who can assume that role, and the second part is that what that role can actually do, right? So in this case, what I'm saying is that the IoT workshop admin role, which is basically the role the Cloud9 instance has been running the whole time, can assume this role, right? And this IoT workshop admin role can also tag a tenant ID as part of creating the session, right? So now basically what we are also trying to say is that when you tag the session ID, you can only list those resources which have the same tenant ID tag, right? So this particular condition within the IAM policies kind of guarantees that, right? So a typical example would be, let's say you authenticate using a user, and let's say you have a JOT token which gets returned as part of the authentication process, and that JOT token have a tenant ID. So what you will do is that you will basically tag the STS token session by passing the tenant ID, and then you will only be returned back the devices, the thing groups that belong to the tenant ID. And obviously, I know that most of it will only make sense once I do it, but obviously, for the interest of time, and since we have already shared the link with you, I'll let you practice this on your own. This is like an exercise for all of us, maybe post workshop, right? So this is the actual statement that creates the STS assume role session, and this is where I'm actually passing that session tag which I was talking about. And actually, once you do this, you will see that if you don't have access, if you don't have the right tenant ID tag, you will actually get an access denied exception, right? So this is basically one way of ensuring that you are only allowed to see resources that actually belong to the tenant using attribute-based access control. So that's one nice feature which we definitely wanted to highlight as part of this workshop. Another feature which we quickly wanted to talk about is a scenario where, let's say you have a tenant IoT device and you want to, let's say, connect to an AWS service, right? Let's say S3 in this case, right? So you can actually leverage IoT credential provider, which is another service which you can use to get temporary credentials. Again, your device certificates come really handy in this case, and you can basically leverage the same device certificate to request temporary credentials to talk to another AWS service. So this is just at a high level I talked about. Again, there are whole steps in this workshop that they'll actually let you do this, Gunnar. But I'll just maybe take a pause here and let you wrap up the show.
Yeah, well, I'm gonna blame Ujwal's window switching thing there. That was we lost a minute of time there. But
Sorry, guys.
No worries.
No.
All right, so yeah, we are 1 minute to go, so time to wrap up. We've pasted a link to the workshop once again, so please check that out. It takes a lot more than 1 hour to go through it all, so this was a quick walkthrough just here. So one final word or sentence from each of you on this solution, maybe to wrap things up. Ujwal?
Yeah, I mean, I would say, you got these concepts, go and build it, play with the workshop, and take this as a good startup for you, and then start building on this top of this workshop.
Yeah, Anubhav, I know you wanted to talk about billing as well. We didn't.
No, I mean, Ujwal already mentioned about the billing groups and how you can. Basically, those are just cost allocation tags which show up in the AWS Cost Explorer report, right? And I just want to mention one last thing is that consider whether you want to create one account per tenant or when you want to go to pool model, right? And also maybe see if there's a hybrid approach in between. So those are very important things to consider, especially because of the AWS limits, account level limits.
And Philipp, finally.
Yeah, I hope you have also learned, apart from SaaS that you know already, a little bit about the IoT portfolio or our main IoT service, IoT Core. And how you can build your solutions on top of IoT Core. And of course, we have a bunch of other IoT services, also a bunch of other workshops. If you want to learn more, feel free to use them or reach out to us.
All right. And with that, thank you all very much. Thank you for joining us today, guys. And thanks to all of our viewers. Bye-bye.
Thanks a lot. Bye-bye.
Thank you.
Thank you. Bye-bye.